For some reason, I can't
see your presentation.
Okay, I'm not sure if I can actually, for some reason the window doesn't, oh, it's kind of broken. That's great. Hold on one second. I'm not sure what's happening.
So we see your PowerPoint presentation.
Yeah, I just can't click on it right now, which kind of defeats the purpose of having it, you might say. Let's see. Okay, did that slide change?
Yeah.
Okay,
Consumption.
great. Yeah, exactly. So today I'm going to read a verse from Jeremiah, as you can see, chapter 17. Blessed is the man who trusts in the Lord and whose trust is in the Lord. For he will be like a tree planted by the water that extends its roots by a stream and will not fear when the heat comes, but its leaves will be green and it will not be anxious in a year of drought, nor cease to yield fruit. So I put the word consumption at the top of the slide because to me, this verse is talking about kind of our intake, what we get from the world around us. We have to be careful where our sources of energy are, where our sources of nutrients, you could say, things like that, right? Because there are so many things in this world that do not give us life, do not give us energy, and yet we will still dedicate time to consuming them. Whereas with God, if we dedicate our time to allowing him to be what we intake, we will be, like this verse says, a tree planted by water, which to be a tree planted by anything else doesn't really make sense, right? Because why would a tree be planted next to something that doesn't help it grow? And yet that's exactly what we do so often. So I just kind of want this to be a reminder for you to take a moment, reevaluate what am I using? What am I allowing to be what fuels me? What am I putting my time and effort into? Is it what is actually going to allow me to grow and thrive like I'm supposed to? Or is it something that's going to kind of steal my life away slowly? So, yeah, I guess I'll pray real quick. Dear Father, thank you so much for this day. Thank you for allowing us to still be together, even though we are not there in person. I pray that this week will go well for all the students here. Anyone who has tests, that they will be blessed in that. And I pray, Father, that you will allow us to consistently pursue you as our source of life and energy, as opposed to so many things around us that try to steal it away from us. Amen. So let me see if I can present real quick. Okay, when I click present, it opens up another window. That's the problem. I see. Okay, so chapter 9 or section 9 is about reversibility. And so the big elements of this chapter are really that when you write code, you should do it with the fact that you might have to change it in mind. So you should always be writing that program, that project, working with the team, however, without a full attachment to what you've done. So they use the phrase that you're imagine that you're writing in sand, not in stone, and that the tide might come in and wash over your writing, because at the end of the day, the programmers are not the people who always get to make the decisions, and even if they are, programmers don't always agree. And so you have to bear that in mind when you're working in a project, that what you're doing probably will not be permanent. And so you need to be careful to not kind of back yourself into a corner. He also makes a point of saying to kind of abstract your program, meaning that if everything you write, for example, is hard-coded or very literal without this room for expansion, or kind of just like data abstraction like we talked about in object-oriented programming, then your program will not be flexible. It will not be able to be applied to other situations or other places, and you will have essentially made something that is a one-trick pony, and probably will be a broken one-trick pony. So don't do that. He also says to don't assume stability. Whatever you're working on, don't assume that it's going to work or that it's going to continue to work, or that the project that you started with is going to be the same as when you end. So be careful about that. Don't kind of fall prey to being comfortable with the program as it is or the project as it is, because things constantly change. And they also say large projects have more inertia, which I thought was interesting because that's not something we really think about a lot, but it's true. if you have a really large project, it's a lot harder to make changes once it's moving, once it's going. And so you want to break things down. You want to take the small parts of it and you want to make those what you change, or the most important parts you also want to break up, right? Because if something is really vital to the program, but you can't change it, then that is just not good. So those were definitely the biggest takeaways that I got from section 9. If anyone has any questions, I guess I could take them, or I can move on to section 10 real quick.
So what was the tip for that? If you can summarize what the tip was for that, or do you know?
Oh,
I can read it if you want, if you like. I have it in front of me.
yeah, that'd be great. Sorry, I don't have the book right.
So tip 14 is there are no final decisions. So that goes into play with the reversibility. So if you don't mind, let's go ahead and pause there for a moment. So how hard is it to do this? And how do you think it might get you in trouble? By the way, great presentation of this material. Anyone have any ideas or thoughts? So one of my superstar programmers, he lived by this, the reversibility thing, and it served him well. He was one of our superstars for just this reason. He'd write code, and if he's struggling to get it work and it's working and it's not working right, he says, okay, let's toss that. Let's start again. But that's very hard. Once you've got ownership, you've locked into ownership of this piece of code, you're just going to keep hammering at it until you get it to work. But sometimes that's not the right answer. Sometimes the idea, the best solution is to throw out that idea and find some other way to approach the problem. It's a hard mindset to come across because we don't want to let go. We want to make this work. We want to fix it. And sometimes that's not the best approach. Sometimes you have to throw it out and start again. And it's also a very hard thing to sell to management, because management's going to resist it. Says, look at all this work, but we're throwing it away. But what they don't see is in the long run, you're actually saving time because you're trying to hammer away at something that you may not be able to solve. And I see that students do that a lot in our projects here in software engineering too, where they get stuck on a problem and they want to keep doing it the same way that they were trying to fix it before, rather than throwing it out and say, oh, what other approach can we take? Now, you don't want to just keep jumping to new solutions every time it gets hard, because of course that's the other extreme. So yeah. All right, go ahead, Nathan.
Okay, yeah. So section 10 is titled Tracer Bullets. And I thought this one was really interesting because it was not about what I thought it was going to be about. So he starts it off with an analogy, talking about how when you're firing a machine gun in the dark, or I guess really any gun, there's two ways to know where you're aiming. One is to just start shooting and hope that you're getting close to the target and kind of see where they're hitting. And then the second is to every so often in the magazine, there is a tracer round that has like phosphorus in the bullet. So when it fires off, it creates a streak, right? And you see this light shine as it flies towards its target. And so you can kind of see this direct line directly towards your target as you're shooting, which will allow you to make sure that your bullets are kind of flying straight and true, right? So moving away from the ammunition aspect and more towards programming, specifically what they're getting at is that you should always know where you are aiming in regards to your project, and you should always be kind of, I guess you could say, updating, tracking, monitoring how close you are to where you're going to be. And so he kind of develops this into not just like a tip, but really more of like a methodology, right? And so it's kind of like an extension onto whatever you're normally doing as your development style. He says that you should begin to program in this way, so that what you're doing is creating your project bit by bit and allowing it to be very close to the end goal, as close as you can get it. And so he says that the benefits of it are that it's lean and targeted, meaning that you always know how close you're going to be towards the end goal because you're not kind of just shooting in the dark. And so he says that it's different from prototypes because typically we're familiar with prototypes as being how close we're getting to the actual end goal, or mock-ups for that matter, right? We see this image or this lower quality project, and we say this is what we want the final result to kind of be like. But he says stop doing that because that's throwaway code. Don't make things and then throw them away and then make something else. Make something, and if it's not close to what you're trying to do, make it close to what you're trying to do. And then he goes into the benefits of why you should program this way. And so I kind of summarized, I think he makes somewhere around 5 or 6 points about this, but I kind of summarized them. So you want immediate demonstration. So someone says, hey, how is this project going? What do you have to show for your work? You don't kind of scrounge around and say, oh, well, like I've written this function and I've done this little bit and like this is in review right now and I don't really have a fully working, prototype. They're like, oh, okay, that's not helpful. But if you have an actual module or function, whatever, but it's standalone and it runs on its own, it can actually demonstrate how close you are to where you want to be. It shows the functionality of the project at its current state. Even if it's not finished, even if it's not polished, you're showing how close you want to get, or how close you currently are, rather. He also describes it as scaffolding, meaning other people around you who are also programming, maybe even different types of programming. So you might have front-end people or database people, whatever, right? They have somewhere to lay their code, their portions of the project. They have something that they can actually put their stuff onto, as opposed to just knowing that something exists and not knowing exactly how it's going to operate. Because that's a pretty common thing when you're working in teams is your expected input and output, but you don't know what it's going to look like. And the end result functionality, hopefully, is what they describe, but it's not guaranteed. And so this can kind of mess with the actual fitting together of the project, which is the next point, bite-sized integration. If you have massive portions of code that hopefully work together, and then one day you mash them all together to create your project, it probably won't work on the first try. And you kind of hold your breath on any team project where you've done this because you just don't expect it to work. However, if you've been consistently integrating smaller portions throughout the entire project so that you have something very close to the end result, you don't have that fear or that nervousness because you already know how close you are to the end result. And then finally, probably the most obvious one is if you are building something that will eventually become your product, you know how close you are to finishing your product. You have tangible progress throughout the entire decision-making, programming portions of it. You know what works, what doesn't, what isn't integrated, all of these things. It's not ambiguous. It's not vague. And so that's the importance of writing code with what he calls tracer bullets, regular checkups on where you are, something you can deliver, something you can show, something people can work with. So yeah, that's what section 10 is about.
All right, so great job, Nathan. So what do people think about this? How does this, oh, let's clap, yeah. Great job, Nathan. So what does this mean to you? What tangible things can you think of based on what Nathan described as the tracer bullet technique? And he explained some of the benefits there, but could someone, yes?
It reminded me a bit of like unit testing, where like you create the environment like by itself, and then you
Right.
test it so that you can show that this part of it works and other things. And
Right, in a sense, except for we're flipping it on its edge in some way. Does anyone know what I mean by that? Probably not. Can you guys see the whiteboard online? Or do I have to tip the camera? Yeah.
It's pretty good if you can hear me.
Yeah, okay. So let's see if I can. right about here. Can you see here online, folks?
Yeah, that's good.
Okay, so, and those of you in my operating system class, remember we had these layer diagrams with these interfaces, right? And so what Jordan was talking about, he was talking about, I just messed up your name, didn't I? Okay. Is unit testing here in this module, right? This is what we test. We make sure this is functioning correctly. And we do it this way so that there's clear roles and responsibility. Everyone knows what they're working on. So excellent. But what this concept is saying is, yes, this is fine, but what about these interfaces? Do you want to wait till the end to figure out that there's something wrong with your interfaces or your way things connect up, or people's understanding about how things are supposed to connect up? So what a tracer bullet does is it goes through these layers and traces through a specific piece of functionality through all the different subsystems. And you want to do that early to tell whether everyone's on point when it comes to the interfaces and integration. So the integration isn't a big surprise at the end. So we've got this unit tested and we know it works in isolation, but do we know for a particular piece of functionality, and that's what you do, you take a vertical slice and you determine whether that piece of functionality will make it through all our layers in our design. So not only is it layers in the system in terms of interfaces, but it's layers between different people, right? And typically each of these layers components will be done by someone else. So now you're also interfacing people and making sure, yes, there was no misunderstanding, or oh no, there is a misunderstanding. Let's get to the bottom of this and figure out where the disconnect is. And you don't want to wait till the end if you have integration all the way at the end and say, okay, everyone's got unit tested, but oh, when we throw it all together, it doesn't work. So that's sort of the idea, big idea behind these tracer goals. Another term that we use a lot is we're taking a vertical slice. So here would be a horizontal that is within the functional module areas, and we do our unit tests, and that's good. You don't want to throw that out, but every once in a while, you're going to want to take what we call the vertical slice, which is the tracer goal. Same idea, slightly different term. So yeah, it's a valuable tool, and please take advantage of it. It's like Nathan was saying, it's not quite the same as prototyping, but in a sense, you're creating some piece of functionality that you can actually show your user. So it serves a very similar role to prototyping in that you're seeing you can actually produce something, some piece of functionality, and demonstrate it to your customer. So great. Well, thanks again, Nathan.
Yeah, no problem.
All right. I'm going to change the settings. So yes, and by the way, if you end up being online, it is a lot easier. And I missed your question in the chat. Do you want me to chat or do you want me to talk? It's easier for you to talk because I'm not necessarily, I wasn't at all looking at the chat window and didn't see it until afterwards. But so I'm sorry I missed that question from you. Let's see. I'm a little disjoint right now because was in charge of my grandsons this morning. Let's see. So I hope you took advantage of your project time on Friday. Don't forget, we have the assignment of the concept description, which is a high-level overview. I think you guys actually did it, but submitted it to the wrong assignment, so you might want to resubmit it.
That's the proposal he did.
Oh, okay, he did the concept description? Okay, okay. But you're working on it, okay. So, online folks, am I sharing I'm probably not sharing the right screen, is that correct? Or in fact, I'm not sharing anything, never mind. Okay, so online folks, can you see?
We can see it.
Okay, great. So that was the devotional, and Michael is up next. Then Tanner. That's a really bad spelling there. Caden. So your new name is Cadam. I'm sorry. McKinnon. And then go ahead, Jordan.
For the concept.
Yes.
We just submit all, we all submit
Is it written down as a group assignment, or can you even see that? You're kidding? I'm the only one that can see whether it's group or personal?
Yeah, not until after you submit it, as far as I've been able, it's still either it's group right now.
Okay, so let me get a browser, let's see. I think it's a group. This is probably going to make me do authentication too. Let's see.
Yeah, it's a group.
Oh, you can see this group. Okay, so yeah, one submission. And what was the indicator on themes that it was a group?
When you press submit, it says you will count for everyone in your project group.
Okay,
So it doesn't show up until after.
until you after you submit. Okay.
I haven't submitted it yet.
Yeah, but you have to click submit.
Yeah, you have to click the first submit button.
Uh-huh.
And
then
it
before you
lets you
add.
input a file, and when it's letting you input a file, it says.
Oh, by the way, this is for everyone.
Yeah.
That's unfortunate that they don't tell you ahead of time. Okay, so yes, this one is a group submission. I guess it doesn't really hurt for everyone to submit a copy, but as soon as the first one does it, you'll know that it's a team submission. But yes, this next one is a team submission, and I believe the next one is too, which is due the day after. It's due on Tuesday, and that is access to your source code repository. So make sure that you guys are getting your source code repository. And I know that the ACM meeting actually had lessons on using Git and having everyone set up with a Git account. Git or Git or whatever they call it. Yes.
Do we only need to like submit the URL to our GitHub page, or?
Basically, I want you to invite me or add me as a user or whatever, depending on what repository you're using. I want to be a viewing member of the project, so I can see and take a look at things, and you can actually link them to me. So yes, I want to be invited into your source code repository, whichever it is. So in terms of people missing, we have obviously the 5 that are online. They're not really missing, they're online. But we are missing Isaac. Is that it? Okay. Let's see, 1, 2, 3, 4, 5, 6, 7. So 5 plus 6. And then, yeah, 7 would be Isaac. Okay, so yes, just Isaac. Great. Yeah, I think Jonathan Dyke is dropping out. Haven't heard from him. Yeah, it's unfortunate. And then, so what we're going to talk about, I'm going to finish up on creating a schedule. We'll go over chapter 14 epilogue. Again, For those of you that are looking ahead, my advice to you is don't spend a whole lot of time studying it per se. Just do a quick read through, and that will be sufficient for the quiz and for the knowledge that I want you to get from it. It's just a overview of some of the current topics in software engineering, and like I said, that's a moving target. So I'm sure it's starting to get a little bit out of date, but chapter 14, and then we're going to have a little discussion on time management as I run into the board. Okay.
Mr. Lim,
Yes.
you said we have a chapter 14 quiz. When again?
I have not actually announced when the quiz will be, but it will probably be after you folks get back. Otherwise, I have no problem with having you do it online, but I haven't set a date for that quiz.
Okay, cool. Thank you.
So yeah, I will give you some heads up, but like I said, it's a very quick read, very quick chapter to read. So if you want to get ahead, go ahead and quickly read through that. Let's see, that was the old devotion that I didn't take out. So this is actually section 4. This is a section in the program Pragmatic Programmer that Isaac didn't cover because his sections, I guess, in the edition that he was using that had borrowed didn't match what my version says. So when is software good enough? So basically it's when do we stop is the big question, because programmers can keep going ad nauseum and make it better. And oh, wait a minute, I wish I had done this. I'm going to change this, and just keep fixing it forever. But the problem is that perfection is the enemy of good. You will never have anything perfect, and if you keep working on it over and over again and refining it and revisiting and second guessing yourself, you won't actually produce a product in the timeline allotted. So your goal is to determine when is good enough. One way to do that is making quality a requirements issue. So actually ask your user how good it has to be up front and make that part of the requirements. The other place that you will see this is in the defect reporting. So as we start doing testing, various defects will be recorded, and that is where a cross-functional team can determine, yes, this is good enough. We're not going to worry about this. We have bigger fish to fry. We have things that are more important for us to spend our time on. We're not going to worry about it. So that is a cross-functional team. So we can both do it as we do it in the defect rating system, or we can do it ahead of time in the requirements where we actually have that this kind of performance is good enough, or various metrics, or you can say we do a usability test. If the usability test score in the user interface testing with potential customers is sufficient to this level, it's sufficient. And the other thing is we don't want to over embellish. So we as software engineers or engineers can come up with all kinds of neat features. And first of all, you may be missing the market of the requirements, and the customer may not really want something that you're providing, and may make it more complicated or make it miss the mark in terms of what actually you want to produce or they need for you to produce. So you have to be very careful of that. And certainly feature creep and requirements creep is something that not only comes from the customer, but can come from the developers. The developers see, well, gee, it would be easy for me just to add this extra functionality and over embellish the system. Now there's a fine line though, because sometimes in your developing, you can come up with great ideas and let's say I've been on a project where something was developed by one of the developers offline because he knew it wasn't part of the requirements and he knew it wasn't part of his job, but it interested him enough that he spent his own extra time coming up with this feature and then demonstrated it to management, and management said, oh, wow, this could make our customer's job a lot easier. And so then went through the process of getting it approved. So there's a fine line, but in general, you don't want to over embellish the project because it results in loss of time, and it also can cause the project to miss the target by going off on tangents that aren't not part of the project. So a big thing is knowing when to stop. So how many of you have the tendency to want to keep making it better and add new features? And yes, Jordan is one of those. Over here we have, yes. And some of you are saying, oh yeah, I know when to stop. It's good enough. But anyway, it's a trap you can fall into. So by the way, has anyone seen Isaac? Is he doing okay? Okay, so he must, hopefully he's doing well. All right. Okay. I can't remember if this was one we looked at before. Yeah, I think it is. So I'm not sharing this, I'm sure. Okay, so here's the Gantt chart that I showed before. Or no, it's a different one. So yeah, it's a Gantt chart using Gantt project, but this was another team's project from the one different than the other one was the TAMS project. This was actually the Badger, so working on Dr. Hootkin's project Badger. So here you can see their schedule, again, the task dependencies, the resources that were put on it, and we have overall tasks and subtasks. We looked at resource charts. This is a way to see how your resources are being allocated. Here we can see that they had not looked really well at their resource chart, so it looks kind of odd because they hadn't focused on it at this point. And we have here that they're displaying the begin date and the end date and the resources, but they're actually not showing the work in this particular diagram. But here you can see if I right click on this header, I can do manage columns, and here we can add columns to display or hide columns from being displayed. So here we have duration, so I can actually add duration. Oops. Oh, that's adding, never mind. Let's see. Scratch that. Adding is add a new field, but let's see. Can I cancel that? Escape. Here we go. Click on duration and then show select. I'm sorry. Adding is adding a new one. And now we can see here the duration shows up in this display. So that's pretty common in Microsoft or project software, project scheduling software. And so you can take and remove columns depending on what you're looking at. So when you're creating it, you definitely want to have the duration. But here they decided they were more concerned about the begin and end dates, and they weren't showing for this particular presentation or this go around the duration. So you can add and subtract what you want to look at from there, much like most other tools that we have, like Office and things like that, or Excel. And let's save it. So those were example presentations for Software Engineering 2. Pretty simple and straightforward because, you know, the projects, relatively speaking, are not as complicated. And let me share this next one. Oh, where'd it go? So online folks, oops, where'd it go? Oh, it's on here. Okay. For some reason, when I share it, it puts it on, changes it, has it change the screen. So here are various projects. You can look at the details of each of these tasks. When I click on them, are down here. So this is Microsoft project. Yes.
Yeah, I have a question. Can you create a project for us on Microsoft? Because apparently we can't create a project on Microsoft project for free.
Oh, really? You can only view?
Like I can't create. So when you try to create, like they ask you for license, and I don't have the admin access to that or anything.
Oh, that would be an IT question. So you went to the link that the, what is it? Microsoft Azure? Oh,
No, it's it's provided from the school. It has all this Word, Excel, PowerPoint for free, but project is in here, but still can't create.
I can create one. That's good.
there's a key.
I'm just gonna follow.
So with, okay, so that's a good point. So with Microsoft Azure, there's a link in the resources page to download it. There is a product key associated with you. So did you create a Microsoft Azure account?
No, I haven't.
Okay, so you create a Microsoft Azure account with your Letourneau email,
Okay.
I believe. Is that what you did? Yeah. And when you download it, it will give you a product key. I actually usually copy and paste that and put it in a file and stick it on your system because you can use it multiple times for Microsoft projects. So if you have a laptop, a desktop, or whatever, you can continue to keep using that same key for all your distributions, and then you will have a license key to install it. So yeah, I'm not quite sure how you downloaded it.
12 months free stuff, or are you using 12 months free stuff, or was it just free?
It was all of the resources tab from.
Right, if you go on Canvas in the resources page, there's a link, and I actually have in parentheses, get Microsoft project here. Yeah. So anyway, was there more?
Thank you.
Okay, yeah. So click on a task and you can see various details. Here's the task ID. So all the tasks are given a unique ID, the type, and what's that? The lag. So this is how much behind we are. But here you can see here that we have various projects and various tasks and subtasks. And just like a Gantt chart, you can collapse them and open them up depending on what you're trying to focus on. But if we look here, we can see there's this one category called gate reviews. So gate reviews in the organization were places where a cross-functional team will look at everything that was supposed to be done and compares it against what was done, and it determines whether you pass the gate. And so you can't go to the next stage of development until you pass that particular gate. You are stuck there. For instance, your requirements aren't quite complete. We don't get to go to the next gate. We have one gate, which was gate 4, which was functional complete. That means you have all the functionality in there. It may still have defects, but it's complete. I think that was gate 4. And then there was commercialization and things. So, but notice how much work is associated with each of these tasks. 0. So that is something unique to a task in project scheduling software. What this is these are milestones. So they are not a task in themselves, but it says we've reached a certain place that is trackable and important to management at whatever level it is. And we want to track this. So this is completion of a gate and these all have dates. This is put up at the very top because this is something that management wants to see right away. So the gates were put at the top. And again, we see more milestones. These are with the software, because this is a cross-functional chart that has more than one team all enveloped into the same project. And so here we see all the milestones for the software team. We have documentation complete, rebranding complete, what's that? Connectivity, USB, enhanced analysis, feature complete, which is one of these milestones that depends on that, and then SQA, so that's software quality assurance testing. So those are the milestones that were called out in the software development schedule. And then we also see the documentation. So actually, the interesting thing about this was our tech writer team. And this actually was created in a separate file and it's been linked in. So Microsoft Project allows you to have various teams do their schedule separately and then integrate it into a master schedule. And so that's what we tended to do because we had cross-functional teams, mechanical engineers, electrical engineers, technical writers, software quality assurance, although I know that Leonid Gruzman tended to go ahead and put his items right into the software one than rather than doing a separate one. But his predecessor, his former boss and predecessor tended to do her own schedule. So here's various tasks, and we can see here we have quite the zoo of various tasks and dependencies. And so it can get quite complicated to manage all these 10 dependencies. And so there is a fair amount of time that's sent into it. Let's see. Here we can see the resource usage. So here are the various people, and actually it's called out which tasks. So here's actually was my list of tasks that I was supposed to do, or I think I hopefully did it. Steve Myers, Leonid, which is our software quality assurance person, Katrine, and Jay, which was our marketing person. So various tasks that the marketing person is responsible for. And then we can go out here and see a chart of how much they're supposed to spend on each item and where we're at. There's different views. So there's quite a lot of sophistication in Microsoft Project. Where's the properties? So here we can also see all the return on investment type things and where are we compared to where we before. Microsoft Project has quite a bit of things along those lines, and so this is a new version of Microsoft Project for me as well as you. Let's see, properties. Here we are. So here we can see here that the start date for this project was April 13th, 2009. Here's the current date, which takes that right directly from the computer, but you could force it to be a certain date if you want to look at it relative to a certain date. And then you start, normally you start scheduling it based on the start date, but you can also look at things from the end date. So basic information that you want to set up for the project is generally the start date and the resources. So the people who are going to be involved on the project, their availability. Like again, like I said, oftentimes it's common to have people allocated at 75 or 80%. I think this organization, we generally allocated each person at 80%, which I think was probably pretty optimistic, but that's what we had them allocated as. And then you can put down vacation schedules. So people, if they know when they want to go on a planned vacation, you can actually allocate that in there too. And therefore, closer track what's really going to happen, because honestly, he's not going to get any work done when he's on vacation, right? When your person, he or she. So that is, oh yeah, and then here we have the Gantt chart and the network diagram, which is the PERT chart, the PERT chart. So you can see here the directed graphs. So the Gantt, and here we are. So you're going to get the opportunity to test this out and work through a project schedule yourself. First cut schedule, I will ask you to refine, and so you'll get extra points on your initial cut for refining it. And then this will also be the basis of how we will look at your progress as we go through the semester on your project. So we'll be tracking this. No to all. Okay, 5-minute warning. So yeah, usually I underestimate how much time I'm going to spend on a particular topic. So I definitely thought I would be doing other things as well. But you can see here, this particular project had the main schedule, and then the technical writers had theirs as a separate project file. Frankly, it is a bit more, it's a little easier in terms of each individual team having their own file instead of having to share a file, so that you don't have to coordinate access to it and not have people editing at the same time. But then the difficulty is you have to make sure you keep these two files together and synchronized. Otherwise, all of a sudden you get this message that I can't find some of your other page, it's missing, and then trying to coordinate what happened to it. Someone moved it around and it's no longer there. Generally, it's easiest if you put it in the same folder, but in our organization, we had a shared drive where each team had their own area. And so now we're not only multiple files, but multiple areas of the disk. They weren't in the same directory. So sometimes it made it more difficult. All of a sudden, you'll see a message that says part of the schedule is missing. We don't know where it is when you bring it up. So that's sort of difficult there. So any other questions about what we were talking about today or about the class? So assignment due to tonight, which was moved from yesterday, and then give me access to your source code repository, so that I need to go take a look at what you're doing. And that will also allow me to collaborate with you if you have any questions, and I can provide some guidance. All right, so you're dismissed. Thank you, people, and thank you, online folks.
Thank you. Have a great day.
Thank you.
Yep.
I added you on the chat.